On August 23, 1948, at 20,000 feet, Edwin Schoch's only way down was a hook above his cockpit and a steel bar hanging beneath a moving bomber. He failed to catch it 3 times. On the 4th attempt, the Goblin hit the trapeze hard enough to shatter his canopy and tear away his helmet and oxygen mask. His jet was built without a landing gear, and he was fighting a problem that 3 decades of engineering hadn't solved. The basic idea had already been tested in the 1930s, when Navy airships USS Akron and USS Macon carried small fighters beneath their airship hulls to extend their reach. They carried Curtiss F-9C Sparrowhawks, connected to a trapeze by a skyhook sitting above their upper wing, with the pilot inside, the engine running, and the aircraft pointed into the slipstream. Recovery was where the idea became dangerous. To achieve it, the Sparrowhawk flew back under the airship and lined up with the trapeze. The pilot closed from below, holding the Sparrowhawk steady until the skyhook caught the trapeze bar. If the hook missed, the pilot had to break away and try again. If the approach was too fast or poorly aligned, the fighter could hit the recovery gear or the airship itself. If the hook caught, the fighter stopped flying on its own. The trapeze took the weight, and the airship pulled it back inside. Risky as it was, the recovery system itself did not claim any pilots, but repeated operations exposed a different weakness. The airships themselves were too fragile. Akron was lost in severe weather in 1933. Macon followed in 1935 after storm damage tore into her tail structure. Without the airships, the Navy's airborne carrier experiment lost the very machines built to prove it. However, the Soviet Zveno program proved that a simpler version of the idea could work. With it, TB-3 bombers carried I-16 fighters into combat, helping them bomb targets in Romania, including the Carnavoda Bridge and Constanta docks. The main difference was that they never asked the pilot to come back. But the US demanded a complete cycle that ended with the fighter returning inside the carrier. To make that work, the next mothership would have to be stronger, more controllable, and built around better recovery hardware. If they fixed the carrier and improved the hardware, the flying aircraft carrier might still work. World War II gave the idea a new reason to exist. Bombers could cross dangerous distances faster than fighters could protect them. Drop tanks and improved engines made that possible, but the longer reach came at a cost. On the longest missions, a pilot could speed 5 or 6 hours strapped in, climbing, holding position, watching for fighters, and managing fuel that was constantly dropping. After the war, the Convair B-36 pushed the problem beyond the reach of practical jet escorts. It could cross oceans, but no practical jet fighter of the late 1940s could escort it for the full mission. So the old parasite aircraft idea returned, no longer as an airship experiment, but as a bomber escort scheme. The Sparrowhawk had done this under a slow airship. The post-war parasite fighter would have to do it under a bomber at far higher speed, in rougher air, with far less room for error. Before trying anything riskier, the Air Force tested the simplest version of the idea: tie the fighter to the bomber and pull it along. In 1947, a Lockheed P-80 Shooting Star was fitted with a nose attachment bar, while a B-29 Superfortress trailed a tow cable. On September 23, 1947, Lieutenant Colonel Pat Fleming flew the P-80 into the disturbed air behind the bomber and tried to hook onto the line. After several misses in the bomber's wake, Fleming finally caught the cable. For about 10 minutes, the system worked. The B-29 pulled the jet through the sky, while the fighter saved its own fuel. Then Fleming tried to disconnect. The tow bar refused to release, and the fighter stayed tied to the bomber. He maneuvered underneath the B-29 to get free, but the bomber's bow wave snapped the attachment point backward and threw the tow gear into his forward view. Fleming landed the P-80 safely, but the lesson was already clear. Once the fighter was physically tied to the bomber, the pilot's freedom depended on the release mechanism. If a fighter could not safely trail behind a bomber, Then the Air Force would try the stranger option: hide one inside. The requirement was this: build a jet fighter small enough to disappear inside a bomber's bomb bay, fast enough to fight when it came out, and armed enough to matter. And after the fight, it had to come back. McDonnell Aircraft answered with one of the smallest jet fighters ever built for the U.S. military. In 1945, the company submitted the Model 27 concept for a parasite fighter, but it would have hung partly outside the carrier aircraft, creating drag on the very bomber it was supposed to protect. The U.S. Army Air Forces rejected that approach, insisting they wanted the aircraft inside the B-36 bomb bay. The result was the Goblin. It was the cleanest test of the idea yet, since it stripped the fighter down until nothing remained except the mission, the hook, and the man. It came out short, round, and compact. The aircraft was about 14 feet 10 inches long, with a wingspan of just over 21 feet when open. At about 5,600 pounds maximum weight, it was lighter than many full-size World War II fighters. To fit inside a B-36, the wings folded upward for storage, while the tail surfaces were packed around the rear of the fuselage. Inside sat a Westinghouse XJ-34 turbojet, producing about 3,000 pounds of thrust, and 4 50-caliber machine guns were mounted in the nose. The cockpit was so tight that pilots had a height limit of about 5 feet 8 inches and a maximum weight of roughly 200 pounds with gear. The fuel load was just as revealing, given that the Goblin carried about 112 gallons, enough for roughly 30 minutes of combat endurance under the original requirement, plus the return attempt. To save space and weight, the Goblin had no landing gear. For emergencies, the prototypes had a fixed steel skid under the fuselage and small spring steel runners near the wingtips in case recovery failed. To get home, the Goblin relied on a hook, a tougher, faster version of the old airship skyhook. The hook sat above the nose, just in front of the cockpit, and had to catch a trapeze under the bomber. The concept was familiar. The execution was not. The Goblin would have to do the same things that Sparrowhawk did at 4 times the speed and roughly 20,000 feet in airflow disturbed by the carrier aircraft. All in all, the Goblin had the speed, guns, and climb of a fighter, but not the independence of one. Once the Goblin left the bomber, the countdown began. If it could not hook back on time, it had only a skid, an ejection seat, and whatever fuel remained. Before this parasite fighter could be approved for production, McDonnell had to prove it could be launched and recovered in flight. That put the whole project on one pilot, Edwin Schoch. Schoch was a decorated pilot and an experienced test pilot who had earned the Navy Cross during World War II. He was also small enough to fit in the cockpit and experienced enough to understand what the aircraft was doing before it got away from him. Inside the cockpit, the seat, oxygen gear, controls, fuel, guns, and ejection equipment were packed tightly around him. Above his line of sight sat the hook. The first flight tests used a modified EB-29B Superfortress named Monstro because no production B-36 was yet available for the program. The bomber's bomb bay was cut open and fitted with a trapeze, stabilizing gear, cameras, and instruments. Testing took place at the Morocco Army Airfield in California, the Desert Test Base, later known as Edwards Air Force Base. Because the modified EB-29 lacked sufficient ground clearance for crews to roll the Goblin directly beneath the bomb bay, they used a loading pit cut into the tarmac. The Goblin sat lower in the pit, allowing crews to raise it into the bomber and attach it to the trapeze before takeoff. To improve Schoch's chances, the rear of the bomber was even painted in high-visibility markings. The aft section was made bright and easy to see, with yellow and black markings on the tail and wing areas. In July 1948, Monstro carried the XF-85 Goblin aloft, with Schoch inside. At first, the fighter remained stowed. Then the trapeze lowered it out of the bomb bay and into the slipstream with the engine off. While still attached, the Goblin began to move. It could sway and oscillate in the disturbed flow beneath the bomber. Schoch tested the controls from the trapeze. The Goblin responded in the bomber's wake, but the recovery gear still held it. On August 23, 1948, Schoch released the hook. The Goblin dropped away from the bomber and flew on its own for about 10 minutes. But the real test was still ahead, getting back. He came in beneath Monstro and aimed the hook at the trapeze. The bomber's wake hit the Goblin like a hand pushing from the side. Every small correction he made required another small correction to fix the one before it. The trapeze was right there, visible and reachable, but the air kept moving the Goblin away from it. First attempt. Miss. He broke away and set up again. Second attempt. Miss. Third. Same result. On the fourth, the Goblin hit the trapeze hard. The canopy shattered. His helmet and oxygen mask tore away. At 20,000 feet, without oxygen, every second threatened his judgment. He lost several thousand feet before stabilizing the aircraft. He did not try to hook on again. Instead, he turned toward the dry lake bed below. With no landing gear, Schoch made a belly landing on the desert surface. He put the Goblin down at roughly 140 miles per hour and let it slide on the steel skid under the fuselage. Schoch walked away, and the prototype escaped with limited additional damage. To the test team, the failure still looked like a docking problem, waiting for a fix. McDonnell modified the aircraft with more trim power, improved fins, and fairings around the hook to reduce buffeting. All of it was meant to make the pilot's task slightly less punishing. Schoch knew this, so while the engineers worked on the Goblin, he flew a P-80 doing dummy docking approaches, practicing the sight picture, the closure rate, the timing. He was training himself to be more reliable than the machine he was trying to dock with. On October 14, 1948, Schoch released the Goblin again and brought it back to Monstro. This time, after a failed first approach, he caught the trapeze. The hook connected. The bomber took the weight. The Goblin came back aboard. Everyone cheered, as for the first time, the full cycle had worked. Launch, flight, recovery, and return. Just to be sure, about a week later, on October 22, 1948, Schoch flew another free flight. The disturbed air under Monstro pushed the fighter offline, and the approach turned into another fight for position. After 4 aborted attempts, the Goblin hit the trapeze bar and broke the hook on its nose. As in the first free flight, Schoch had to take the aircraft back to the lake bed. Again, the Goblin came down without landing gear. Again, the steel skid replaced the recovery system the aircraft had been built around. Testing continued into 1949, but the numbers moved against the program. The 2 XF-85 prototypes completed a total of 7 free flights, for a combined 2 hours, 19 minutes of flight time. Only 3 ended with successful hookups. The others ended with missed recoveries, damaged equipment, or belly landings at Morocco. Each repair made the machine a little better, but each flight still asked Schoch to be almost perfect in conditions that combat would only make worse. The results never became reliable enough. On October 24, 1949, the XF-85 program was cancelled, with Schoch being the only pilot to have flown the aircraft. But that cancelled the aircraft, not the obsession. The Air Force still wanted a way to carry a smaller aircraft to the far end of a bomber's range without making it fly the whole mission under its own power, and the Goblin had at least proved the idea viable. So the question changed. If the tiny internal fighter was too difficult to dock, could a larger fighter be carried another way? That moved the program from McDonnell's XF-85 to Republic's F-84 Thunderjet. The next version was meant to give pilots back everything the Goblin lacked: a real fighter, landing gear, more fuel, and a normal cockpit. That idea became Project Tip-Tow. This was an attempt to escape the Goblin's worst compromises. Instead of carrying a tiny aircraft inside a bomber, Tip-Tow used full-size Republic F-84 fighters, coupled wingtip to wingtip to a modified B-29. Since the F-84 had landing gear, it could operate like a normal aircraft after release. It had more fuel, more space, and more capability than the Goblin. If something went wrong, the pilot had more options. To return to the bomber, the F-84 pilot flew alongside the B-29 and connected to a coupling mechanism at the bomber's wingtip. Each fighter carried coupling gear on one wingtip, which locked on to matching hardware on the bomber. Once it was locked in place, the fighter basically became part of the wing, riding along with its engine shut down to save fuel. The F-84 pilots still sat in the cockpit, ready to fire the engine back up, break away, and fight if they had to. At first, only one F-84 was attached. When this proved successful, the system was expanded to allow two to be attached simultaneously, one on each wingtip. The first hookup of both F-84s came on the program's 10th flight. On September 15, 1950, the modified B-29 flew with both EF-84Ds connected. On October 20, 1950, the three aircraft combination stayed joined for 2 hours 40 minutes. For a short time, Tip-Tow seemed to be the answer to the Air Force's quest for a parasite fighter. The idea promised more than fuel savings. In theory, the attached fighters also acted like wing extensions, increasing the effective aspect ratio of the bomber's wing and reducing induced drag. The same wingtip connection that made Tip-Tow attractive also made it unstable. With the added weight, the B-29's wings flexed mid-air. Air also rolled off the wingtips and disturbed the fighters attached to them, adding to the issue. Even after attachment, the fighter pilots still had to work the controls to keep their aircraft aligned. Roll control was achieved through elevator movement, rather than through ordinary aileron input. In that sense, the result was the opposite of the goal. What was supposed to be a method to reduce pilot fatigue became an added workload. As such, the Air Force tried to engineer around this issue. If the pilot could not comfortably hold the fighter steady by hand, an automatic system might take over part of the job. Republic received another contract to add automatic flight control to the Tip-Tow setup. This would allow the pilot to connect to the bomber, shut down the engine, and let the control system help hold the fighter in place. And sometimes, trusting the system was the most dangerous thing a pilot could do. On April 24, 1953, the system was tested over Peconic Bay off Long Island. The test aircraft was a modified ETB-29A with coupling gear at its wingtips. Two EF-84Ds flew with it. One of the fighter pilots was Major John Davis. The other was Major Clarence Bud Anderson. Davis brought his F-84 in toward the bomber's left wingtip and made the connection. The coupling held. His fighter was now locked to the B-29. Earlier tests had been plagued by electrical problems, especially the reliability of power from the B-29 to the fighter's automatic controls and data recorders. This time, Davis believed he had power through the coupling. Then he shut down his engine. For a few seconds, the F-84 became a ghost plane. He'd handed part of the aircraft's control to the automatic system. The fighter was carried at the end of the bomber's wing, held in place by hardware and electrical power. This was the dream in its purest form. A fighter carried without burning its own fuel, held in place by hardware and automatic control. Just then, Davis's F-84 pitched violently, then flipped upward around the bomber's wingtip. Because it was locked to the B-29, the motion did not stay with the fighter. It drove into the bomber's wing. Explosive bolts fired to jettison the Thunderjet, but not in time to prevent the collision. The F-84's nose was torn away. The B-29's left wing failed outboard of the engines, and the bomber went into a steep spiral before crashing into Peconic Bay. The link that was supposed to add stability instead caused a failure. The fighter couldn't simply drop clear, and the bomber couldn't take the impact. Once the automatic system failed, the entire structure trapped both aircraft. Davis and 5 men aboard the B-29 did not survive. Anderson survived in the other F-84 after his aircraft separated safely from the formation. Major John Davis did what Schoch never could. He handed part of the recovery problem to the machine, and the machine betrayed him. The accident ended Tip-Tow. The escort version had now failed twice, once inside the bomber and once on the wingtip. But the larger idea still had value if the mission changed. If a parasite fighter was too dangerous as an escort, maybe the solution was to go back to a reconnaissance aircraft. The version that came closest to service was FICON, an acronym for Fighter Conveyor. It attempted to keep what worked and remove what had made earlier systems dangerous. From the Goblin, it kept the idea of carrying the parasite under the bomber. From Tip-Tow, it kept the full-size Republic F-84. What it dropped was the Goblin's tiny gearless aircraft and Tip-Tow's dangerous wingtip coupling. The result was a modified F-84 carried semi-recessed beneath the belly of the Convair B-36. It hung from a trapeze mounted in the bomber's bomb bay, with part of the fighter tucked up into the carrier's underside. The mission also changed. Instead of escorting bombers, the parasite aircraft would handle strike and reconnaissance work. The B-36 would carry the F-84 most of the way toward the target. The smaller aircraft would release near the target area, fly the exposed portion of the mission, and then return to the carrier. After that, it would hook onto the trapeze and be pulled back under the mothership. At Edwin Air Force Base, the system completed 170 airborne launches and recoveries, proving it was far more workable than the Goblin or Tip-Tow. That alone put FICON in a different category from both of its predecessors. The difference lay in the aircraft used. The F-84 was a full-size aircraft with landing gear, more fuel, and normal flying qualities, and it was not locked to any particular part of the bomber. If recovery failed, the pilot had more options than Schoch had in the XF-85. Even then, recovery was still demanding. The pilot had to still fly almost perfectly under the B-36, hook onto the trapeze, and let the carrier draw the aircraft back into position. Even once the system was judged tactically workable, it was never easy to use. On December 12, 1955, an RF-84K suffered a partial hydraulic failure during a night operation. The pilot still managed an emergency retrieval onto the trapeze. In another stretch of testing, after 13 successful hookups, light turbulence and less experienced pilots damaged 3 fighters and the carrier's V receptacle. Even with a pilot who was not exhausted, injured, or low on options, combat would make every recovery harder. Weather and darkness would make it worse. The system worked, but only inside a narrow set of conditions. The problem was still making the return routine enough to trust in combat. Fortunately, by the mid-1950s, better answers were arriving. Aerial refueling directly addressed the range problem. The KC-97 had entered service in 1951, using a Boeing flying boom to pass fuel to another aircraft in flight. A fighter no longer had to be carried like cargo if it could take fuel and keep flying under its own control. Meanwhile, the U-2 approached the reconnaissance problem from another direction. Instead of carrying a smaller aircraft toward the target and recovering it afterward, the Air Force could send a purpose-built, high-altitude aircraft to do the mission alone. Air-launched missiles kept the useful parts and removed the weakest. They could be carried by a bomber, released near the target, and sent beyond the carrier's own reach. But they did not need a cockpit, oxygen gear, or an ejection seat. Most importantly, they did not need to return to the mothership. The same logic runs through later drones and swarms. A larger aircraft can still launch smaller machines, extend their range, and send them into places too dangerous for the carrier itself. That was the future the Goblin hinted at, even if the technology was not ready yet. America never stopped wanting aircraft that could carry other aircraft. It stopped asking a pilot to come back.